Bonsoir tout le monde. Welcome everyone. Thank you for joining us for this third lecture by Harold Varmus. And today he'll be talking about the topic of publications, and actually once more he was a bit of a pioneer in thinking about open publications, open source, open sharing of information, and I think he's been thinking about this for a long time, so I'm very happy to hear him on this. Unlike what he said, this isn't a boring topic at all. I think this is a burning topic, so it'd be great to hear what your thoughts are on it and how we should be thinking about the future. Thank you, Harold, so much.
Okay, Edith, thanks once again. For those of you who have been to previous lectures in this series, you know that my topic for all four of the lectures is the enterprise, the way in which scientists not only think, but organize their thoughts, do experiments, get confirmation, work as a community to try to bring the fruits of their labors to public benefit. And there's no more important way that this happens, in my view, than the way in which scientists describe their results and bring them to public attention and to the attention of other people who need to know about their results in order to advance the products of science for societal benefit. So this is an essential element in the scientific process, and it's one that I think deserves this hour of attention. My wife feels a little skeptical about that. She said I need to sex up the title, and so let's think about this as an activity that brings fame to scientists, money to people who commercially benefit from the applications of science, brings success to many who labor in the fields of science, and also when the system fails, or when publications describe things that are inaccurate or the product of scientific misconduct, it can bring people down pretty quickly. And my objective here today is to spend about half the time, maybe a little more, talking about how we ensure that the results of science, which is largely supported by public money or by philanthropy, is brought to public attention. How does access to scientific results for the people who pay for the science, for the people who need to know because they want to build on the results of others, get made accessible, especially in an age of the internet where free access to scientific results to anybody around the world should be possible if we can work out a financial scheme for doing that. So that's what I'll talk about in the first roughly 55% of this talk. And then I'm going to talk about some other issues that affect publication practices. And while this will have some implications for broadening access, it will also talk about some of the generic traits that are exposed by publishing, including scientific misconduct and reviewing and other things that are pertinent to the scientific process. So let me begin by saying a few things about why publication is important, because contrary to what Edith implied, I think some of you might have thought this was too boring to make it worth coming over to the Collège de France, but I myself have devoted a lot of time over the last 25 years to thinking about that. And one of the themes here, as I talk about access, will be the fact that I didn't pay much attention to it before a momentous event that I'll describe to you shortly. So I think I've made clear already that transmitting the results of scientific activity carried out in institutions and of many kinds is a central goal of the scientific enterprise. If you do the work and don't tell anybody about it, it's as though it didn't happen. And that makes publication and transmission of new knowledge essential. Second, there's this thing we call the historical record, very important in many aspects of science, including the lectures I'll be giving here this month, and establishing what is very important to most scientists, that is saying, I was there first. And the way to prove that is to look at the historical record, which is engraved in the journals that are published by the scientific community. then critical to many aspects of the things I'll be talking about today is the fact that publication, achieving a publication record, having that record embossed in the most important journals, we'll talk about what that means in a moment, and is essential for getting training positions, getting jobs, getting into academies, winning prizes. It's important in the development of commercial products because, for example, the issuing of patents becomes important. And as you'll hear near the end of the lecture, accusations of misconduct and non-reproducibility of published results depend, of course, on publication and what emerges from the publication process. The importance is also emphasized by the fact that a lot of sectors of what I would call the scientific enterprise, the public that pays for it, publishers, funders of the science, institutions that house scientists, and of course the scientists themselves who are authors find publication to be of critical importance. Indeed, when I wander the halls of any of the institutions I've worked at in the last 20 years, the chat is often as much about where people have gotten their papers in press as it is about the results themselves, showing how central publication, where you publish, has become in the lives of people who populate the scientific establishment. This is not to say that this is a good thing, but it's something that we need to discuss and will a little later in this lecture. And then one of the things that makes this a very timely topic is that publication practices have been changed over time, over centuries, but especially over the last 20 or 30 years by new information technologies, beginning, of course, with the printing press, but made much more dramatically different by the rise of the internet, by many aspects of computational sciences, social media, as I'll mention later, the rise of artificial intelligence or AI. All of these things are affecting the way in which publication practices are carried out. And then finally, there is, as you might imagine, a serious discussion of how we pay for all these things, because publication has its costs and they must be paid. And the way in which that's done affects the profit margins, as I'll say probably repeatedly. Traditionally, the large publishers and scientific societies in the more public sector have benefited dramatically from the way in which publishing is done. Publishing a scientific paper creates a monopoly. Papers are only published in one journal, and the result is that the prices that are levied for subscriptions or for the so-called page charges can be very high when people desire to see a certain journal or to have their articles appear in a certain journal. So it's possible to jack up the profit margin here far beyond what exists in many industries, to the tune of 30 or 35% over the actual costs of doing business. So let me just very briefly indicate the wide expanse of scientific publishing, that is, communicating results of scientific work, to remind you that there's been a long history, but a very rapid change in the way things work. So there was a time when nothing was published, when we didn't even have the tools for making manuscripts by hand, and there was presumably a time that we know very little about when people made observations about the sky or about the landscape, or did very simple experiments, and they just told friends that this had happened. And then there was a time when people started writing on parchment and writing down the results of their observations, and that was, of course, true in the ancient world of Greece and Rome. But things changed when Gutenberg invented the printing press, and suddenly books started to appear. And indeed, for a couple of hundred years after the invention of the printing press, almost all scientific work that was communicated broadly was communicated in books, in which an author would say, an author scientist would say, I'm ready to to publish my thesis and would write a pretty long book and would finally determine it was the right time to publish it and find a person who would print it, and that's the way things were done. But in the early 1660s, the Royal Society of London began to publish a journal. Not terribly long afterwards, Compte Rendu began to be published here in France. This was a radical change because suddenly there were shorter articles describing the kinds of experimental work that we see in contemporary journals, and this led to a radical change in the way in which publishing happened. Starting in the late 19th century with journals like Nature that were very widely circulated, there was a tremendous proliferation of journals founded by private publishers, by scientific societies, by governments, and by others that led to the appearance of literally thousands of scholarly journals in the natural sciences. There are now well over 6,000 independent journals describing natural sciences and many others in the social sciences as well. And then in the late 20th century, as computational science became more and more important, digital technology and the creation of the internet completely changed the potential for distributing scientific work by putting it online and making it accessible to anybody who had a connection to the internet. So that is the background in which the rest of this talk will occur. I'm not a historian of science. I'm an observer and an activist, but this is the framework in which it's useful to think. So I want to begin now with a little bit of personal history. Those of you who were at my first lecture know that I experienced tremendous acceleration when my first scientific work was published, work that I carried out at the NIH when I was converting from being a clinician with some academic aspirations to a basic scientist, working on a problem that was actually first created here or first identified here at the Pasteur Institute by Jacob and Monod. That is, how is cyclic AMP how does it become a regulator of expression of the lac operon in E. coli? And people I was working with, particularly Ira Paston, had discovered that cyclic AMP helped to overcome repression of expression of the lac operon by glucose. And when it came time to publish a paper showing that cyclic AMP reversed catabolite repression at the transcriptional level, I submitted a paper to the Scientific Society for Biological Chemistry, and they, after sending me a detailed and very informative and helpful review of the paper, accepted my paper. I was excited that I was now allowed to transfer my copyright to them and to see this paper appear and be read, presumably, by the thousands of members of that society who received that journal. And that was only the first step in a career that has now lasted over 50 years, in which my career was based on many papers that were published in journals that were accessed by largely by individuals who had paid for subscriptions to those journals. I, as an author, as I've indicated, turned over my copyright to the journal. I didn't get any money from the journal for being an author, even though the journal was obviously selling subscriptions to to university libraries, individuals, members of the society, anybody else who wanted to see what was in those journals. Then, because of my growing gratitude toward these journals, I began to serve as a so-called peer reviewer, spending hours every week looking closely at submitted manuscripts to decide whether they should be published by that journal, giving advice to the authors about how the paper could be improved, working as an editor of other journals, receiving peer review statements from people I solicited as reviewers. All this work being done totally for free as part of my academic responsibilities. I didn't object to that. But of course, for these journals, whether they're private sector commercial journals published by large companies like Elsevier and others, or whether they were scientific societies that were seeking to support the activities of their society, holding meetings, supporting young scientists, and so forth, all of these entities that were carrying out the publication process were intent on maintaining their fiscal integrity and boosting profits and bringing in money that perfectly reasonable. And so I was a loyal subscriber, usually through my own laboratory grants, and I read these journals and felt a lot of gratitude without thinking too much about whether the journals were taking full advantage of things happening around us, especially the rise of the internet, to make their work as accessible as possible to people who paid for it, the general public, paying through taxation, and through other scientists who might or might not be able to afford subscriptions to those journals. But life changed on one fateful day late in 1998 when I went to at that time I was the director of the National Institutes of Health and living in Bethesda, working in Bethesda, Maryland, living in Washington, D.C., but I had returned to San Francisco where I had lived and worked for over 2 decades. And during that trip, met for breakfast with a fellow shown here, Pat Brown, a brilliant molecular biologist who had worked with me and with my partner, Mike Bishop, to try to understand how retroviral DNA integrates, developing an in vitro integration system. Pat went on to become a professor of biochemistry at Stanford, but some of you may know about him more recently because about 15 years ago, he left Stanford and academia to become the founder of a company called Impossible Foods, which makes meat-like substances out of proteins that are engineered from yeast genes, and has become the leader of a very large company that's selling millions of so-called impossible burgers all over the U.S. and probably even in France as we speak. So Pat is an original and a highly so-called innovative person, and Pat's discussion was interesting. He told me about a so-called journal club he conducted with his lab, in which he and his students talked about how scientific results are transmitted, especially in the age of the internet. And what I learned from Pat was that the internet had the potential to radically transform how science is published, because you don't need to print thousands of copies on paper of scientific results and then mail them to subscribers. Instead, it was possible to make one copy online and put it on the internet and make it available essentially at that point free of charge. Although obviously there was some work that went into making the copy that would be posted on the internet. Although very few journals were using this modality, even some that were subscription-based were offering internet-based access to digital versions of papers, even then in the late 1990s. But as we discussed during our conversation at the Tassajara Bakery, it was clear that a whole lot more could be done to make access to essentially everybody possible. And then Pat told me the most important thing, which is that in some fields, especially in physics and related fields, such access was being achieved through something called the archive preprint server. Well, what is that? Well, in the fields of physics, math, astronomy, computer science, and a few others, there was a willingness on the part of the investigators to follow the lead of a brilliant physicist named Paul Ginsburg, who was then working at Los Alamos. He's now had been at Cornell for a couple of decades. And Paul had established a site on the internet called Archive, A-R-X-I-V. And it was possible for people in the disciplines that had signed up to work with him to take a new manuscript, to post it online for about $50 for each paper. Everybody who had an internet connection was able to access the paper. There were tools made available for people in those fields to make comments about the paper. Do you like it? Do you not like it? Can you identify faults? And the authors of the paper were able to respond to those comments, make new versions that were then posted in turn. And finally, when they were happy with the paper and criticism was minimal, they would submit the paper to a traditional peer review process at a traditional journal. So this had the effect of bringing new results to interested parties at a very early stage, knowing that it might not be the final version would be a published version. And this seemed like something that the biomedical community ought to think about. So there were two major outcomes of that conversation at the Tassajara Bakery. The first, when I went back to Bethesda, sat down at my office at the NIH, I decided to write a proposal. This was probably not politically wise, but intellectually and ethically, it was the right thing to do. I wrote a proposal that was called eBiomed, a term that's now only remembered by those who were around at that time. And the idea was to promote much wider use of the internet, to distribute the results of biomedical science. And for the next quarter of a century, especially the next 10 years or so, I spent a lot of time dealing with advocacy for these ideas and a lot of conflicts with publishers and with scientists who did not want to see the current system, or was then the current system, change at all. And we have seen, as I'll describe, a lot of important but gradual changes. Things did not happen nearly as quickly as I had anticipated. So what did this document, this tract, eBiomed, have to say? Well, here's some excerpts from the version you can still see online. And then you see this was published just about 4 months after I had met with Pat at Tassajara Bakery. And it alludes to the fact that we do now live in an electronic age with internet connections. And I say, perhaps somewhat immodestly, that the NIH has addressed the new opportunities created by the digital world by proposing a new system, which we then called eBiomed. You'll see that term has faded away, that has many advantages over the existing means of disseminating results findings. It is open access, anybody can see it, greater speed, reduced costs, and the potential for an expanded depth of presentation by publishing full data sets and much more detailed description of scientific methods and additional data that was previously alluded to in papers as data not shown. As I emphasized at the end of this document, I said that the single greatest attraction is that all of the scientific content of eBiomed will be available without barriers to any user who has internet access. And more specifically, the eBiomed proposal included three major components that we're going to be talking about in a little bit more detail. And the first was to expand on what then existed at the NIH, an inventory of published work in a format that was familiar to most scientists as PubMed. PubMed had the listings of all articles published in certified journals, showing the title, the authors, and the abstract, but not the full text. One could read what the conclusions might be, but you could not examine the papers in that way. You will only see where they were published, who published them, and then you'd have to go to a subscription-based journal to see what was actually said and done. But here, the idea was to create something that contained the full text of all papers that were considered reputable. The second element was to make access totally open, that is immediate, cost-free, and with full text. And that would be a criterion applied to papers after being peer-reviewed. And in addition, part of the library would be designated as a place for papers that had not yet been subjected to peer review in the spirit of the archive effort carried out in the physics community and led by Paul Ginsberg, as I've described. And this would be a so-called preprint domain of eBiomed. But much as there was excitement in some quarters about this, there was a hell of a lot of resistance. To me, the high point of, or the low point of the effort at resistance came about when the leader of my congressional committee that wrote the law each year that provided a budget to the NIH called me in and said, "Harold, I've been approached by a former colleague who's now the lobbyist for the American Publishers Association, and she said you're trying to destroy the capitalist system in the U.S. by which publishers do great things and make a lot of money." And I had to try to convince him that I wasn't trying to destroy the publishing industry. Indeed, I was just trying to change it. But the publishers, both society publishers, often most vehemently society publishers, and publishers in the commercial sector, recognized that one of the byproducts of the effort I and my colleagues were making would be to reduce the profit margin, which was then extremely high. So what did happen in the face of all this controversy? Indeed, the controversy was not only stimulated by commercial publishers, but by many of my colleagues who were very wary of anything that might change a system to which they had become, as I had been, very loyal. And I remember spending many days at the National Academy of Sciences debating the virtues of what we were trying to do against my friends who were loyal to journals that had treated them well and done good jobs publishing their papers over the years. But we were able to do some things even right at the start. In that year, 1999, we were able to announce that we were going to have a full-text library called not just PubMed, PubMed Central, linked to PubMed, but all we could do, because we didn't own the copyrights, was to try to persuade existing journals to turn over their content to PubMed Central. That was not particularly popular. People recognized the advantages of having articles openly accessible to the entire world, but they considered their ownership, their copyright control over such articles to be something that is part of their business plan. And like other businesses, they wanted to maximize profits for their shareholders and for themselves. And there were very few journals that were willing to participate. There were already some so-called open access journals, mainly the journals that were incorporated into a group called Biomed Central, and also a few journals published by high-minded organizations like the National Academy of Sciences in the US itself, and a few others that saw the potential of what we were proposing and agreed to provide their content, but usually only with an appreciable delay of up to a year before putting the articles into the library. The second thing was that open access publishing began on a small scale, mainly through the existing open access consortium that I mentioned a moment ago, Biomed Central, and something that I will describe in more detail in a moment, Public Library of Science, or PLOS, or PLOS. And then, but the idea of publishing preprints, publishing things that had not yet, that is, putting into a public domain things that had not been reviewed, was so largely unpopular, despite the experience in the world of physics and related disciplines, that initiative was temporarily dropped, but I'll come back to it in a moment. So about a year after all this happened, after my meeting with Pat Brown and San Francisco, I left the NIH for another job, but I took on many responsibilities trying to advocate for some of the things that were in the eBiomed proposal, efforts that through Public Library of Science, through open access journals, and through preprints to improve the access to articles that describe biomedical research. And I tried to do this in a variety of ways, usually adding on to lectures I would give about the cancer research I was doing, with a plea to enlarge access. One approach was to stress the history of generosity in the scientific community, talking about how an anatomist, a surgeon, an anatomist in Holland in the 17th century used cadavers he was able to expose at a public hearing to teach members of the Dutch hierarchy many attributes of human anatomy. But I asked my audiences whether they were willing to share their learning in the same generous way. I also pointed out the benefit of medical journals that were openly accessible in public digital libraries to people who were trying to do science in parts of the world where they simply couldn't afford subscriptions to journals that had high subscription fees, which was true of most of the learned journals in our fields. And I stressed a paradox that science in America and elsewhere helped to create the internet, but at least in biomedical sciences, we had been very slow to take advantage of this to improve both the nature of scientific publishing and especially the way we communicate by making results accessible to anybody from disease advocates to colleagues in the same field. During this period, when very few journals were willing to take on the responsibilities of or accept the opportunity to turn over their content, even after 6 months or a year delay, to libraries like PubMed Central, a few of us, especially Pat Brown, who I've introduced to you before, another very aggressive and successful molecular biologist and computational scientist, Mike Eisen, and I decided to open an organization we called Public Library of Science, an advocacy group that was intended to encourage the growth of PubMed Central. And one of the first things we did was to write a petition for our colleagues to sign, because we knew that many of our colleagues were sympathetic with the goals of a greater access. And we signed a petition that said that we would not provide free services as reviewers, as editors. We wouldn't provide our manuscripts, turn over copyright to journals that refused to provide their content after some period of time to Public Library, to PubMed Central. And the great number of signatures was reassuring, and I thought was going to be highly influential, but in fact, it had very little influence, because even the signatories of this document said, well, I believe what I signed, but I'm reluctant to take the necessary steps that I agreed to, because my trainees need jobs, and they can't get jobs if they don't publish in these journals that are not turning over their content to PubMed Central. So I really can't, in good conscience, follow the dictates of the petition that I signed. So that became pretty frustrating. And after a couple of more years, we decided the only way to make this work was to change the way publishing is done and to start our own publishing house that would be committed to publishing everything through open access. And furthermore, to establish journals that would have high credibility, would be carefully reviewed, a high level of rejection of papers, just so we knew we were publishing the best and the most frequently cited papers. I'll talk about citation indices in a little bit later. But the notion that we had was that we would create highly prestigious journals that everybody wanted to publish in which access was immediate from the day that reviewers said that the paper was ready to be published, and that the authors or their grants would provide the money that was required to cover the publishing costs. We raised money from a number of philanthropic organizations, and in October of 2003, we began to publish our first two journals, PLOS Biology and PLOS Medicine, and shortly thereafter began to publish specialty journals in genetics and pathogens and neglected tropical diseases and other things, including one journal called PLOS One that published results of all kinds in biomedical science, where the reviewers were instructed not to worry about importance, but only about scientific quality. That is, if the work was well done, regardless of what the results were, how important the results were thought to be, the work got published. And so we operated with a high acceptance rate. We were able to keep the costs of publication relatively low, and that journal allowed us to stay out of bankruptcy and became extremely successful, and indeed was imitated by many other journals that were subscription-based. This is just a picture of the inventory of Public Library of Science at one time, and we often liked to draw comparisons between what we were doing at Public Library of Science through open access publication with what goes on in subscription-based journals. For example, to use one particularly attractive punching bag, the Elsevier Publishing House in Holland, we contrasted that open access publishing, which is free to anybody who has a connection to the internet, with the subscription-based journals that often had annual subscription fees of hundreds of, if not thousands of dollars, that the only cost in open access publishing would be covered by fairly modest fees that authors would cover through their grants, or would be excused if the authors didn't have adequate grant support. The authors would retain copyright. All the contents were deposited in public libraries like PubMed Central. Whereas in contrast, if you publish in subscription-based journals of the common type, you knew that the publishers were reaping a huge profit margin, that the publisher now controlled the copyright that you should be controlling, and that the contents would not be in a public library in the vast majority of cases. And these steps, the creation of Public Library of Science journals, the arguments we made in many places, did begin to change things, but as I'll indicate in just a moment, the really big changes occurred only after the funders, governments and those who funded biomedical research, and suddenly realized that the work that they were supporting wasn't being distributed to the public in an aggressive manner, did we make real success. Now, the other thing that has come about now 15 years after publication of eBiomed is the viability of preprints, the distribution of articles that had not yet been published in biomedical research. You'll recall my discussion or my presentation of the work of Paul Ginsberg in physics and related fields and the creation of the archive biomed preprint server in around 2015 or so. My colleague from UCSF, Ron Vail, became a very strong advocate for the use of preprints and documented that interest with a little cartoon that shows how preprints are available to everybody in the globe, how rapidly they could be provided, how quickly they unlocked access to new ideas, and And he also created a small organization called As Soon as Possible Biology, an organization that has been a very effective advocate for the rise of preprints. But the effect of developing these preprint servers has been more dramatic than most of us would have expected, largely because of the pandemic. So those of us who were involved in trying to promote the use of preprints online and access to them, the goal was to allow immediate communication of findings, emulating what had been seen in physics and other fields through archive, and the ability of authors to receive constructive criticism before their papers were officially published in journals after peer review, and also providing a basis of public disclosure for making patent claims. But there were a lot of objections to preprints, as has been true of every advance that we've tried to promote in publication practices, with concerns about the loss of priority, that you might be scooped if you put your work onto a preprint server, and then someone else submitted an article to a regular journal that describes similar findings. That, of course, isn't true. There's a time stamp on articles that are published that are presented on preprint servers, and that priority is given to those articles that appear at the earliest possible time. There was misinformation. There was concern about the idea that clinically related results might misinform physicians if the work had not been subjected to peer review. There are a lot of reasons to question that assertion as well, because clinicians every month are going to clinical meetings and presenting new findings that have not been peer reviewed. There was concern that things that were on the papers that were presented on preprint servers might not be viewed as accomplishments by funders of science, but actually NIH and other funders do now encourage the use of preprints, and no responsible journal can exclude papers that were posted on preprint servers first, indeed in part because of the history of archive in physics, where journals like Nature and Science have routinely accepted papers that were previously publicized through preprint servers. And now there's a fairly wide level of support of the use of preprint servers for biomedical research. And part of this happened because two very reliable servers, one called bioRxiv at Cold Spring Harbor, one called medRxiv at Yale, have been very reliable and rapid in their posting of preprints, and in part because of the pandemic, in which it was recognized that scientific results need to get out there fast. And pretty apparent in a pandemic that if you have a sequence of the genome of a new strain of coronavirus, you need to get it to the public, the scientific community as quickly as possible. So judgments can be made about whether we need changes in vaccines or changes in therapies. And then people who worked on other fields said, well, wait a second, I know the pandemic is very immediate and very important, but the work I do is important too. And I'm trying to improve the lives of patients with cancer and neurological diseases and allergies. And why shouldn't my work be just as swiftly displayed and made available to the scientific community? So this has had a tremendous effect over the last 9 years or so, since the possibility of presenting preprints online has been emphasized in 2015, and now upwards of 30 or 40% of work in our fields are being posted as preprints. So it's worth asking. I've described some successes here: more open access journals, the establishment of PubMed Central as a viable force, and the rise of preprints. So what has happened? Well, first of all, funders have come to recognize the importance of access. The U.S. government, the U.S. administration have both mandated deposition in a public digital library. This happened initially through a congressional act in 2008, when Congress, led, I should say, by Republicans as well as Democrats, said that the public is paying for this science, public ought to be able to see it. That will allow a delay of up to a year before papers become part of PubMed Central, but that was a big change and drove the number of papers of work supported by the NIH that were in PubMed Central up to about 70 or 80%. And when the NIH made it clear that there would be penalties for not posting such articles, the number has become close to 90%. Now the Biden administration has made a mandate that has yet to be fully implemented that will require that all papers of research supported by the NIH will be available immediately upon publication. And that's a radical change, but it's echoed by other changes driven by other funders, by the Howard Hughes Medical Institute in the US, by so-called Plan S in Europe, where multiple funders in many European countries and a few in the States as well are requiring that all that work be open access. There's still details about the payment of publication fees that have yet to be worked out, but I'll say a word about that in a moment. But this is radically changing the approach to open access publication, because it basically is going to be mandated by the funders. The journals have understood that these mandates have to be honored, and they have recognized that while open access publishing may be a little less lucrative, it too can be pretty rewarding financially, especially if you use some tricks of the trade that I don't have too much time to describe. But some journals, for example, are currently hybrid journals. That is, they charge subscriptions to traditional subscribers, but authors can elect to pay an open access fee and to improve their revenue stream. And then scientists are increasingly embracing not only the principles of greater access to the literature, but the principles of open science. That is, that science is a public activity sponsored by philanthropies and taxation, and that open science is more productive, collaborative, and gratifying. And part of that is opening science to public access. Now, I need to say a couple of things about in the context of these improvements that indicate that we haven't solved everything. That there are costs to open access publishing, and that demands that money be recovered from somebody. It can be the funders themselves, or it can be countries that want to support an open access movement, independent of what they spend on the practice of science, and usually the costs are usually covered by what are called article processing charges, which can be high enough that people working in either on very limited budgets in rich countries or working in poor countries simply can't afford. And the other problem is that there are quite a few publishers who recognized that by limiting the costs of the publication process, by providing a very weak reviewing system, peer reviewing system, and by shortchanging on production costs, they can make money from even fairly modest author charges, and they are frequently advertising, trolling the scientific community for articles which they propose to publish on the assumption that scientists are sometimes naive enough to think that publication anywhere is useful and good for their careers. And these so-called predatory journals that have been feasting on the willingness of some scientists to pay what are in some cases extortionist prices to get something published has been poisoning this process and making people accuse open access publishers of simply being vanity presses that are only available to those who can afford to pay for them. And this is an unfortunate development that needs correction. So there are some solutions to these problems. They're not complete, making people view the size of an article processing charge a basis for selecting what journal to publish in. You can make the pricing competitive. That hasn't really happened very effectively yet. There is the ability to negotiate prices with funders or with institutions, and that has been happening in many contexts. There's some new funding methods available to try to eliminate these costs, so-called diamond open access, which is still not fully defined as one of those approaches. And then we simply have to educate scientists about the practices of so-called predatory publishers who are simply trying to publish anything to obtain small amounts of money that sometimes large amounts of money that simply are intended to promote the careers of people who can afford to pay for them and not improve the doing of science. Still, I do think that over the last 25 years or so, we have been changing the culture of science, and people have decided in general that we are going to work to find ways to share information, not to lock it up in the form of medieval monkish libraries. And that's been done largely by creating public digital libraries of full text that are now quite complete, and by developing new methods for open access publishing and for encouraging the growth of preprint servers and that also provide avenues to seeing open data. And so that is where we stand with access. And I wanted to talk in the last 10 minutes or so about the fact that even though we've improved access, there are other problems that have yet to be solved in the publishing world. First, peer review remains imperfect, and it's too slow, it's uneven in quality, not necessarily viewed as a transparent process in which people provide the kind of fairness to authors that we would like to see throughout the publishing industry, regardless of whether the publishing is subscription-based or open access. And there are some answers here. I think one way to improve the process is to make reviews open, not divulging the names of reviewers, but showing the reviews themselves so people know that when they write a review, it's going to be posted online with the paper either before or when it's published, and responses to those reviews by the authors can be included. And one thing that I've long hoped for is that we would open up the dialogue between authors and readers as well as reviewers by using the internet for open commentary even after publication, to try to make papers that are truly important be the topic of continued conversation between authors and their readers. The second issue that is incredibly important to the publishing industry in general is the way in which evaluation of careers and the steps in career growth have been based on not on an actual reading of papers and evaluation by scholars, scientific scholars, but instead have been based on a quantitative measure called the journal impact factor and other quantitative measures that differ in nature. This world of what we call bibliometrics was initiated by a physicist named Eugene Garfield, who clearly had the qualities of genius, but also has sown mayhem in the scientific community, in my view, because he's developed this number called the journal impact factor, which is based on the average number of citations of all papers that appear in a certain journal. And if your journal is grouped with others that are frequently cited, and that means there are a lot of people following a field and obliged to cite the papers in that field, those journals will. Those papers will confer onto a journal a high impact factor, and there are a lot of consequences of all this. First, this provides a very simple tool for someone who's sitting on a search committee or making decisions about whether to accept someone into one's laboratory. One can simply say, well, how many papers have been published in the journals that have the highest impact factors? That leads to an overvaluing of papers that appear in a fairly small number of journals that have extremely high impact factors, because the journals are read by a lot of people. They do publish some very important papers and some lousy papers. And the shift that has occurred is from a situation in which people who are responsible for evaluating the accomplishments of an individual and making decisions about the development of their career don't base those decisions so much on an actual reading of what that person has produced, but instead by a review of where the papers have been published. Now, there are some institutions, I know that Edith leads one in Heidelberg, the EMBL, that have made a concerted effort to direct their faculty to make evaluations based on what's actually been written by candidates for jobs, candidates for promotion, candidates for prizes. But in general, in the U.S., the approach that unfortunately our trainees believe is here to stay is to count the number of papers people have published in journals that have high impact factors. This, to me, is a derogation of responsibility and an undermining of scientific integrity that I'm quite worried about. And one of the things that's been produced as a result is a logjam at the journals that have very high impact factors, especially the journals that I refer to as CNS journals, Cell, Nature, and Science, in which an extraordinary number of papers are submitted for publication. They're excellent papers, but they get rejected on one grounds or another. Then they get sent to another high-impact journal, and the publication process is inordinately slowed by this. Furthermore, one of the reasons that open access publishing has been not endorsed as widely as I would have liked over the last 20 or 25 years is because people feel that they must publish in these so-called high impact factor journals, and that they take risks by publishing in journals that don't have the high impact factors that very few journals do. So this has been poisonous for the transmission of scientific information, and we need to find ways to overcome some of these problems. I think leadership in the scientific community is critical here. In my own experience working, for example, as president of Memorial Sloan Kettering, I've insisted that appointments and promotion committees actually read papers. We can change the way people describe themselves, not just by listing the papers that they've written and where they were published, but by describing in longer paragraphs what they've done to make a contribution to science, referring to the work they published, but describing in plain language what contributions they made, whether it was the invention of assays or an idea for doing something spectacular. There's no reason why we have to depend solely on the names of journals in which papers by an individual have appeared to make decisions about the quality of their work. Another continuing problem is that time to publication is just too slow, and one way we can restore that is by encouraging preprint servers, as I've mentioned already, by encouraging journals to work together so that papers don't get sent from one journal to another, but instead journals use a team of reviewers and then share the reviews, and journals can select the articles they want to publish. And I think even more importantly, it's time to restore to authors the way authors made decisions about when to publish long ago, by saying to an author, here are the reviews, we're going to put the reviews online. If you want to publish your paper in our journal, you can. The reviews will be attached. If they're critical, people will see them. And at least one prominent journal, a journal called eLife, has taken that position, and I personally endorse the process. Now, I want to finish with just a couple of words about something that's linked to publication, in some sense a separate process, but not entirely, and that is the rise of the apparent increase in frequency of results that are either viewed as not reproducible and hence thought of as not reliable or correct, and manipulated findings that represent scientific misconduct in published papers. And these publications, when they're shown to contain results that are either not reproducible or are manipulated in some fraudulent way, they tarnish science at a time when science is under attack, certainly in America, and I believe some places in Europe as well, for overstating its conclusions, for engaging in practices that are not reliable, and the undermining of science, often with ulterior motives that relate to climate change and to vaccination practices, has been a very negative force in American science. And let me just say a couple of things about that as I perceive it in the U.S. First, it was drawn to the attention of many of us over a decade ago by people working in pharmaceutical firms developing therapies for cancer, that many published results that encourage the development of anti-cancer therapies couldn't actually be replicated when efforts were made to do so at pharmaceutical companies. And this was often due, as could be well documented, by inadequate methods, by flawed design, especially statistical analysis, and by flawed interpretation of results. The other thing that is at least as worrisome is the identification of changes in manuscripts or aberrancies in manuscripts, including copying previous work, plagiarism, fabricating results, or actually completely falsifying results are being detected in increasing numbers, with more papers being retracted. These numbers are small, but they are significant and get a lot of attention. Just recently, for example, a major cancer center in Boston was reported to have decided to retract a large number of studies that had what might be thought of as minor aberrancies, but nevertheless aberrancies that reflect inappropriate practice of science. This problem has become so pervasive that the New York Times decided just a couple of months ago to publish an essay by an individual who's currently devoting her career to detecting such aberrant results. And in the New York Times appeared these pictures of radioactive, well, not in a sense radioactive, but results of experiments in which gel electrophoresis was used to generate one set of results, and those results were then presented as the findings in other experiments and additional papers. So the images that you can see on the left that were in one paper were then slightly stretched and in one case flipped and tilted in a second figure in a second paper. And this kind of manipulation, of course, is a fabrication of results. It doesn't, in all instances, change the general conclusions of the paper, but often it represents an effort by trainees in laboratories to attempt to make papers look nicer and therefore be accepted in so-called high impact factor journals. There are open questions here. We don't know exactly what the frequency is, although we're getting a pretty good idea because Elizabeth Bick is not the only person who's spending a lot of her time, his time, looking for these aberrations, so they will be increasingly frequently identified. We don't know what the impact of these findings is going to be on the enterprise overall, but people are losing their jobs, losing their grants, as these aberrations are discovered, and we don't entirely know what the right remedies. Paper retraction is probably not enough. Punishment of individuals who commit these essentially fraudulent acts need to be figured out. These folks don't get brought before courts of justice. They are evaluated by institutions and sometimes by the NIH, sometimes by outside committees and lawyers, but rarely by the courts. One way I see to try to improve the situation is to deal with the training process for scientists, emphasizing not just the findings of science but the design of experiments and what is allowed and what's not allowed, and have clear expectations of the kind of behavior that are required for the honest conduct of science and for the rigorous conduct of science. And many of these things are happening, but they're happening in a highly pressured situation and not perhaps as quickly as we'd like. So I need to add just one footnote here about scientific meetings. We've been talking about dissemination of scientific information. Of course, that doesn't all happen through publications. It also happens through scientific meetings, large and small. And that's always been an important way to distribute new findings, even without peer review. And that has been an important factor in the swift communication of scientific results within the community. When it's done in a meeting that people attend in person, there is the additional advantage of interactions that lead to collaborative work and provocative discussions. But I am concerned about the effect of the recent pandemic on this process. Attendance is lowered at institutional seminars and at meetings. There are many more virtual events conducted through Zoom and other media applications. These events are sometimes productive and useful, but they don't have the component of person-to-person contact that I think is essential to the proper function of the scientific community. And I think we don't know yet how long these patterns of change will continue, and what the consequences of losing those personal interactions that occur at meetings where people talk directly to each other. So I think there's remain, as most of you can see, many ways to try to improve the value of the scientific information that we try to communicate to each other. One is to continue to enlarge access to published results. Another is to think about ways to improve the way scientific findings have been traditionally presented on paper by using digital tools to change the format of papers and create papers of the future. We need to do things that I've mentioned in the context of non-reproducible and even fraudulent results to improve the integrity of the scientific record. Artificial intelligence is the topic of the day. It's going to have an effect on the way papers get written, and we need ways to control the use of this important tool that's not detrimental to the integrity of science. And then I think in a broader sense, we need to be integrating the scientific literature itself into the way people get educated about what science is, and another way to popularize the results of science and things that get published in scientific journals by improving and creating better opportunities for people to have careers in science journalism. And finally, all these things combined will help us to combat what I view as a growing distrust of science throughout the US and I believe in Europe as well. So what I've tried to say today in a nutshell is that publication is an essential feature of the scientific enterprise. It's flawed in many ways. We've made a lot of improvements. There's a long way to go. Next week, I'm going to talk about another topic that is partly related to this one, but about how the scientific enterprise can be made more accessible to the entire world, that is, allowing people of talent anywhere to contribute to the scientific process and make the findings of science beneficial for the entire world. Thank you very much for your attention. Be happy to take questions.